And welcome to PROD 1125, how Intel and SUSE support SAP workloads. My name is Christian Holsing. I'm a technical account manager inside of Intel covering our OSV partners. So please take a look at the disclaimers in terms of performance results and hardware availability, as especially performance results are done in specific conditions and they might vary. So when we look at Intel and SAP, then there is a long-standing relationship between two companies. Intel has been the development platform for products like SAP HANA for years, and with the announcement of the latest fourth generation Intel Xeon scalable processors, there is quite a set of additional advantages that we are making available to our customers, and I would like to take you through these um, things today and give you a quick glimpse. So, if I'm looking at an SAP project and in the current economical setup, there are various reasons why customers are looking in updating their SAP environment and basically investing into a new hardware infrastructure. So, the three main reasons to do so are business transformation, which is that people are really trying to change the business processes, the way they do business, the way they operate, and basically move to a new platform, a new software platform, which brings usually new hardware with it, and digitalizing more things, for example, and they need a new basis and start over for this. Second reason is operational excellence. So people try to optimize what what they are having and do more with less, for example, and extending processes in a way. So that's the second key driver. The third key driver that we see is IT transformation, which is a TCO thought, for example, just on being able to consolidate IT systems into a smaller footprint, lowering carbon emission and the carbon footprint a company has within IT. So those three drivers we see, and they all have different implications onto the system. It's really from how can I optimize my spending and reduce total cost of ownership on the far right on this chart, over to how can I actually generate more revenue and potentially support my customers better with bigger end-to-end processes and the support of modern IT capabilities like AI that are also coming into play here in the SAP environment. How can I really bring all these capabilities into my business and make use of them? So it's really different motivators that we see and different demands. Um, of course, we also see this from a DSAG perspective and the investments that customers are having in these tough economical times, going out of the COVID times and the inflation that we all see right now. It's really changing how companies are driven, where the incentives is, and after people were holding back for the last couple of years on their IT investment, they are now actually starting to reinvest. And of course, there is the question of how do I move forward? Do I implement in my own data center? Do I go to a hosting provider? Am I using public cloud deployments? So it, I think this is very individual how companies look at it and which direction they are leaning towards. But really, in the end, from an Intel perspective, with the fourth generation Xeon scalable processors, we're there to help them and support them and provide the benefits of the new CPU generations on the various deployment modes. So from a Xeon advantages perspective, going back to where are customers and what does it mean for an SAP transformation, right? So there is really the question of where is a customer in within their SAP transition. So a lot of customers are just doing a rehosting, replatforming of their environment, and still with the support of the older ECC SAP releases with any database below it. Even there, we can provide advantages here because the CPU is just so much more powerful that either you get more capacity to grow or more spare capacity for your processing, or as I said before, you're able to consolidate multiple systems and, for example, virtualize databases, NetWeaver instances, and with that reduce your footprint. It's really a replatforming, rehosting approach. Um, Even if you're not moving to HANA right now and you're not there at this point, it might be really interesting to look at the latest hardware platform and the latest generation of CPUs just to enable the system. If you do a, for example, replatforming right now and just replace the hardware as a next step, you're probably as a company looking to move to HANA. If you haven't done so, and with the modern and latest generation compute platforms, you will just be able to have the capacity build that in, and then without by purchasing an additional set of hardware, just being able to migrate um, from a NEDB over to SAP HANA. So the support is simply there, and that should give you peace of mind. And as you will see, there is quite a bit of performance gains in the latest generation. And of course, there is also the greenfield, and I think this is pretty much a no-brainer for people, for customers migrating from an ERP system, a non-SAP ERP system, over to an SAP S/4HANA system. You definitely want to start on the latest and greatest hardware platform, the latest and greatest software, as well as SUSECon, of course, from a SUSE perspective, and just get peace of mind in terms of not upgrading or having to plan for large upgrades that take your system down and mean outages for your business in the end. So really the value proposition from an Intel perspective here applies on all the three pillars that we see here. If I'm just rehosting, we think we can provide significant value here. If you move to HANA, there's obviously significant value here in the cooperation between and the collaboration between the three parties, SUSE, SAP, and Intel. And also for the greenfield approach, you want to start on the latest and greatest platform. And this is basically a way how you can look at it from a process perspective to some extent if you do the rehosting and replatforming on SAP ECC. There is the case of either just doing the direct migration to S/4HANA or just replatforming with ECC and NEDB and then move to HANA as option A. The option B, the migration from ECC to S/4HANA, which is pretty simple, pretty straightforward, and C from ECC to RISE on premise or in the cloud. Well, obviously it's mostly in the cloud, and then there are also the cases of BW as well as the greenfield approach with D and E. So if we talk about performance, here, for example, we've done obviously a set of tests. You can look at the validation reports and benchmarks, of course, that our hardware partners have published. But just to give you kind of an idea, what we see here for SAP HANA is basically up to 2.3 times better OLAP performance. through the based on the latest technologies like increased memory bandwidth, AVX512, and other technologies that we bring to the market from an Intel perspective. But I think where it's really more significant is we're working on increasing the limitations of the database sizes that we've seen on the previous generations. So we expect to really get to larger HANA databases. So the memory per socket ratio is expected to grow to 2 terabyte. It's been below that before. And we're looking at this right now, which if you just simply do the math and looking at the large 16 socket servers, then you will be able to move from 24 to at least 32 terabytes in the near future. So that's all happening, and just simply by lifting and shifting a HANA database from a third or second generation Xeon to a fourth generation, you will be able to leverage these benefits. Maybe not right now, but over time, because as I said, we expect these certifications to be issued in the next few weeks and months. So hardware readiness, this is a statement of last month, May 2023. So as I said, 16 sockets, 32 terabyte, that's actually in the process of being certified. 8 socket and 16 terabyte validations are done. They are available from our partners HPE and Supermicro. Check them out. And 2 sockets and 4 terabytes, we have a broader certification and availability in the market right now. Again, check out the SAP hardware directory, and you will stay up to date with the latest certifications from an Intel and OEM perspective. And of course, there's a very close collaboration with SUSE happening in the background, because hardware and the database isn't working without a properly supported operating system. And just talking about the SUSE and Intel partnership right here, what you probably don't see as a customer is what really goes into the collaboration and the engineering. So what is pretty obvious if you start thinking about the engineering relationship, then Intel releases a new CPU. We release improvements. We're one of the largest contributor to the Linux kernel, which all is upstream. But the upstream kernel, the upstream patches need to be integrated into a Linux distribution like SUSE Linux Enterprise Server or upcoming adaptable Linux platform. So there's a lot of work that happens on a daily basis between the engineering teams to provide this set of integration. And seeing what patches need to be integrated, work on the side effects, troubleshooting, so that you as a customer get a operating system that supports the Intel hardware in the best possible way and gives you the benefits and enables the latest hardware features throughout the software stack. So the patches and the integration in the SUSE code stream is one thing. There is also joint testing. So, of course, SUSE is building SUSE Linux Enterprise Server. From an Intel perspective, we're taking it, we run this through the same tests and ensure that basically the behavior of the patches and the performance that we see in our labs is also available for the SUSE product here. And that is just the typical open source collaboration you would expect towards the operating system. But there is, especially in the SAP space, a longer history here of where we collaborate, where we work together. And just to call out a few examples, and I mean, I can personally say this with confidence, having been on both sides, on the SUSE side and the Intel side here. There is really a strong collaboration to look into better monitoring of the whole stack. Very recent topics that I'm going to talk about at the later part of this presentation, like confidential computing. How can I protect the compute in public clouds, for example? much better than the whole notion of performance and TCO. As I said before, right? I mean, we bring with the fourth generation Xeon better performance, but the OS needs to enable that. And even if I'm thinking about virtualizing SAP workloads, right? There's a lot of engineering work in the background that happens with the hardware vendor and the hypervisor and the operating system to really tune and optimize performance throughout the whole stack up to the SAP application. Right? Because that ultimately plays into the total cost of ownership, and a couple of percent of improved performance or lower CPU utilization might allow you to host another development system next to your existing ones. Right? And then there's the whole notion of cloud deployments, which is, as I said before, becoming increasingly more important. And really, from that perspective, these are just a set of areas where we're collaborating and we're working outside of just the pure engineering work between SUSE Intel together to get a joint, a mutual benefit to our friends at SAP. So one of the projects, again, that has been very prominent from a SUSE side is Trento, the ability to check the configuration of an SAP system based on rule sets against its optimal and consistent configuration. But there is also the question of hardware telemetry. And we've been talking about this for quite a while. To see how can we actually make progress here and look at predictive monitoring more than actual monitoring. Because if I'm thinking about a HANA database in the end, it's fine if my monitoring system tells me I have a problem with the system and I need to restart. But actually, in the whole context of a high available SAP system, I would want to know these predict outages that are probably happening in the near future early on. So from an IT operation perspective, I can start to plan for it, right? And this is not only for software. This also is absolutely important on the hardware side. If I'm thinking about memory and the time, if you go back to what a 24 terabyte HANA just simply takes to restart, and we're pushing this to 32 terabyte now, so it will take even longer. And on a DIMM failure, as a customer, I would definitely want to get a fair warning that my latency on a certain DIMM is increasing and I should worry about replacing this in a few weeks. That gives me a chance as an IT service provider to plan for the outage and use the SUSE HA technology and everything to just keep the database, in this case, available, instead of just being in a situation where I'm having an unplanned outage and I'm failing over, and potentially, as a lot of customers use the same hardware and the same DIMMs, it's not unlikely that you see similar issues also on your second node, right? So there are pros and cons in terms of setting this up, but this discussion is ongoing between Intel and SUSE, and we definitely want to bring more to the market here and see how can we use the knowledge that Intel engineers have in terms of understanding what's happening on the hardware side to bring this into Trento and the monitoring of the SAP environment and really provide benefit this way. Security is another key topic. So I already spoke briefly about confidential compute. I will talk about this in the future. But security is really front and center of a lot of CIOs and companies at this point, and it's really starting from how do I protect workloads? What technology do I have in the cloud if I'm just basically renting a VM and have no control what's running next to my virtual machine on the very same physical hardware? It also goes to the question of kernel patching, firewalls, HA obviously plays into this. So it's a very complicated topic and broad topic. And from an Intel perspective, we'll really keep innovating and working with our friends at SUSE to see how can we take the Intel innovation through the previously described upstreaming process into SUSE Linux Enterprise, and so slash for SAP. Going forward, what makes sense here, and what can we do? So, talking about confidential computing, this is actually one of the latest innovations that we have on our fourth generation Xeon processors, and I've also done a session here at SUSECon Digital on just confidential computing. But if you think about it, and I don't want to go too deep in this session, the premier use case that we see right now is the public cloud. So I'm going to any of the public cloud providers, and what I'm renting in almost all cases is a virtual machine, but I don't know what's running next to it. And I might just put the heart and soul of my business, my ERP system, or another critical system over to the cloud. And yes, theoretically, the cloud provider could get access to your virtual machine, like your admin could do this through VMware hypervisor, for example, or KVM. They get access to the virtual machine as much as they could get access to physical hardware. And simply from that perspective, we believe that confidential computing is going to be an emerging technology, and it's going to be more and more critical with people moving to the cloud. And the three things that confidential computing introduces here from an Intel perspective and also from competitor technologies is pretty much the isolation of workloads. So the first promise is I'm starting to isolate one VM from the other, that even if there's a problem in separating the workloads from each other, there's no way that a process within one virtual machine gets access on the physical machine to the memory of another machine. So I think we all remember some of the issues that we've seen a few years ago in the industry. So isolation is the first promise. The second promise here is really encryption and control. So the implementation that Intel has done, and that's TDX, it's technically encrypting the memory that a virtual machine is using, and it's using a specific random key per virtual machine, which means that, as I said, in the cloud, you might have two virtual machines running next to each other, and both use different keys, so that even if for whatever reason I might have access to the underlying hardware, the virtual machine is using a different encryption key. And even if I'm having physical access to the machine and I do a memory dump, the data is useless at that point because it's encrypted. And the third aspect is verification, which basically means, in the public cloud, I'm renting something, and I have absolutely no control about the machine and how it's built up. The verification service, it's also technically called attestation service. The promise of these services is basically that you get some independent verification that the machine that your VM runs on is properly configured, doesn't have any changes in the bill of material it was shipped with, and that you have basically these end-to-end encryption. So this is all building up. Again, if you are more curious, take a look at my other session where I explain this a little further. From trusted execution environments perspective, just to go back to a technology that we have in market from an Intel side since a while, there is SGX and TDX. So TDX is really trusted domain execution. And the difference between SGX and TDX is basically that on the third generation of the Intel Xeon CPUs, SGX was available, and you had to use a Intel SDK to basically take part of your application and move this into a security enclave. That was the level of confidentiality. It required the developer to actively do something. You could also move whole functions out, so it wasn't that complicated, but it was a change in the code. What TDX actually does is, through the isolation of the whole virtual machine and encrypting the context of the whole virtual machine, you basically do not need to do any change to your application, really. All the magic is happening on the operating system and the hypervisor. And operating system is both the host and the guest. To enable it, but just from an SAP perspective, you can just take an SAP workload, put it into a TDX-enabled virtual machine, and there is no changes. And we're just looking into it from a performance perspective and obviously an SAP certification perspective. So stay tuned on that. I also just read a blog post from our CEO, Pat Gelsinger, who was talking about the Intel SAP relationship. That should also be available when you see the session if you search for it on the internet, right? And without TDX and SGX, I really need to trust my computing provider. It's easy in the data center because that are probably your employees or the hosting provider. But really, if I'm looking at it, there is a good middle ground here that we introduce with TDX to really, without huge changes, getting confidential computing enabled. So from a TDX availability perspective, from an Intel side, we're just looking at the cloud service providers to start with. There is a blog post from Microsoft who has actually announced private preview a few weeks ago of TDX-enabled instances. If you're interested, you can take a look at that. Alibaba and Google are in the same ballpark, and I think IBM is working on it. They've announced that they work on it. If you're an IBM Cloud customer, feel free to check their websites and see if the TDX-enabled instances are already available. We're looking at a broader market availability right now. TDX is available with the cloud service providers, but like early next year, end of this year, with the next generation of CPUs, code names Emerald Rapids, we're also looking to bring this to on-premise and hosting customers with their own data centers. And that will also obviously increase the spec of TDX. So right now we're implementing version 1.0, 1.5 is on the horizon, 2.0 is basically being spec'd out as we speak. So basically, to wrap this up, there is a strong and vibrant relationship and collaboration between SUSE and Intel. In the SAP space, I just gave you a glimpse. It's pretty hard to do it complete in 30 minutes, but there is really the work on S/4HANA deployment. How can we make this better? High availability. The whole question of recovery. It's not only the operating system side. There's also the question of what can we do from a hardware side to increase processing speed, throughput, and those kind of things. That needs to be enabled again. Cost efficiency, I touched on quite a bit with more compute power that the fourth generation provides. That should help you to achieve these goals, administrative efforts, and protect workloads. That's all in the security barrier. So stay tuned. There will be more information, more white papers that we're working on. And if I'm just looking at it from an Intel Xeon perspective, just to recap where I started with. So there is a huge performance increase with the latest generation up and more addressable memory with up to 32 terabyte. It allows you to consolidate more workloads onto the same machines, which helps you to reduce operational costs on the environment, or being able to grow, and that also leads through lower carbon emission through modernization and consolidation of your SAP landscape. With that, I'm wrapping up here. Thank you for your attention, and hope to see you in Munich.